Greatest common factor. Same is what it sounds like. When you were looking for the greatest common factors for between two numbers, this is that same concept. But now you're including some variables, so you're including some terms. Right here you have a binomial. These are binomials. This is a trinomial because it has three terms. So you want to make sure you pull out the greatest variable and the greatest number, the greatest common factor, the greatest number, the greatest variable that the terms have in common. So if you look at this first one, only the first term has an x. This term does not have an x. But between the 18 and the 27, what is the greatest common factor? Now, if you don't remember your greatest common factors, that's when you would say, okay, I have like 18, and you would list all the factors of 18. The factors of 18 are the numbers that, what do you call it? I always say the multiplications of 18. So basically the numbers that give you 18 is essentially what I'm saying. So you would have 1, 2, 3, 6, 9, and 18, right? And then same thing for 27. What are the factors? What are the numbers that make up 27? You would have 1, 3, 9, and 27. And you say, okay, out of these numbers, what's the greatest common factor? Well, they share a greatest common factor of 9. That's the same concept that we're doing here. So both of these, I can factor out a 9. And if I factor out a 9, what happens? If I factor out a 9, what am I left with in the parentheses? 9 times 2, x would give me the 18, and then 9 times 3 would give me the 27. So 9 times the 2x gives me this 18, right? And then 9 times the 3 gives me this 27. So it's almost like you're doing the multiplication backwards. You're doing the distributive property backwards. And that's pretty much our goal. And the way you check yourself is what I just did. If I take 9 times 2x, do I get 18x? Yes. If I take 9 times 3, do I get 27? Yes. So then this would be my final answer. So if you can remember this from grade school, that's exactly what we're applying here. Okay, so now let's look at this second one. Now we have 3 and we have 6, right? The greatest common factor between 3 and 6 is obviously 3. But what's the greatest common factor between x squared and x? And you're like, well, that looks weird. Well, if you think about it, for x, it's just what? 1 and x, if you want to say that. And then for x squared, it's 1 times x times x. Well, what's the greatest number of x's they have in common? Right, is a single x. So if you want to think about it that way, and you really don't even have to have the 1, because 1 times anything is anything is what it is. I'm sorry, 1 times anything is anything. 1 times what a number is, whatever it is. But when you do these, you say, well, what's the common one that they have in common? And it's just a single x. So if I factor out a 3 and I factor out an x, what is left in the middle? Well, 3x times what will give me 3x squared? Well, I need an x, right? And then 3x times what will give me 6x? Well, I need a 2, right? So then you're like, let me put my 2 in there. You need a 2. Does it work? Well, how do we check to see if it works? We do the distributive property. 3x times x gives me 3x squared. 6x times, 3x times 2 gives me 6x. So this would be our final answer. Okay, so now we have this trinomial here. Same concept. What is the greatest common factor for this? What can we factor out? Well, let's see. If we just look at the numbers, we have 9, we have 18, and 27. Well, 9 will go into 18 because 9 times 2 is 18, right? 9 times 3 is 27, and 9 times 1 is 9. So it looks like the greatest common factor between all of these is going to be 9. So I'm going to pull out a 9 first. Okay, so I've taken out the 9, and then I'll put this here so we can see what we have left. So the 9 will do these, right? And then what about the x's? This has 4 x's, this has 3 x's, and this has 2 x's. Well, all of them have, what's the least amount of x's that they have, or the greatest amount of x's that would cover all of them? This is x squared times x, right? This is x squared times 1. This is x squared times x squared. Y'all see that? So each of them have an x squared, right? This has an x squared, that has an x squared, and that has an x squared. So I can pull an x squared out of each of these terms. So let's pull out an x squared. And we'll come back and check ourselves. So again, 9x squared times what will give me 9x to the 4th? 9x squared times what gives me 9x to the 4th? Well, I already have the 9, right? And I have 2 x's. I just need how many? I need 2 more, right? So then this is going to be x squared. And then 9x squared times what will give me a minus 18. So 9x squared times what will give me a minus 18x cubed. Well, we know 9 times 2 will give me the minus 2 will give me the 18. And then I already have an x squared and I just need one more. So that looks like that's going to be a minus 2x. And then 9x squared times what will give me 27x squared. So 9x squared times what gives me a 27x squared. Well, 9 times 3 gives me 27, right? And x squared times 1 is x squared. So it looks like we just need the 3 to get the 27. So this will be plus 3. At any point, let me know if you have questions. So let's check ourselves. 9x squared times x squared gives me 9x to the 4th. 9x squared times a minus 2x gives me a minus 18x cubed. And a 9x squared times 3 gives me a positive 27x squared. Looks good. So that's factoring out the greatest common factor. You pull out the largest number and then the largest x that you can pull out, or the largest y, or the largest z, whatever the variable is, you pull out the largest of that.